First of all, good afternoon for all, and thank you for the organizers of the conference to invite me to give my talk as keynote speaker. So my presentation is entitled How to Solve the Energy Crisis by Nanotechnology. So first of all, we would like to take an overview about the world primary energy consumption by fuel for the about 3 years ago. So the majority of the consumption of the energy is using the oil, around 31%, followed by the natural gas, then coal, followed by the renewable energy with a limited percentage of usage, up to 7%. So here is a scheme of the electricity from energy sources of all kinds. Okay, so it's seen here that the electricity could be coming from nuclear energy, tidal waves, fuel cells, organic waste, coal, gas, wind, oil, biomass, and sun. So here is, just to show you, the infrastructure of the energy consumption. So what have been your biggest energy challenge in the last year? So is it starting with the supply chain? So facing the challenging and overcoming operational efficiency and managing education caused by energy constraints and supply chain volatility, followed by the carbon reduction, represented by, instead of using fossil fuels, we are focusing on energy transition and using renewable energy, but the availability of the same has been quite low due to climate change. And the infrastructure, we have not been able to build microgrids for our use due to lack of information and knowledge. And finally, the energy volatility represented by the energy demand and consumption are increasing rapidly. Dealing with the rapid shift is a biggest and challenging task for all of us. So here is more than 60% of energy used for electricity generation is lost in conversion. So here is the idea, how to reduce the losing of energy due to biggest percentage of losing. So here we need to insert a new idea presented by the nanotechnology. The biggest laboratory worldwide is National Renewable Energy Laboratory, where it focuses the research on different types of techniques and materials to explore the best efficiency of all kinds of devices and cells to generate the energy, starting with the elements, compounds, alloys of different types of alloys, ternary alloy, quaternary, and quaternary alloys. With a condition put by the United Nations, we are eager to follow up the Sustainability Development Goals. There are 17 goals. So this is very important thing to follow up the instruction of the United Nations to keep our globe safety, green, and sustainable. This is an example of generated 15 megawatts using wind turbine located in Norway, okay, for the stadium of the capacity 28,000 persons. So now we need to get an idea about the nanotechnology as known by 10 to the power minus 9. So where head of a pin is 1 millimeter, ragweed pollen is 20 millimeter, red blood cell is 2.5 micrometer, and carbon nanotube is 2 nanometer. So you can compare the size or dimensions of nanometer represented by CNT carbon nanotube with the other micro sizes. Okay, so currently the nano energy is introduced into wind energy, solar energy, nuclear energy, hydrogen storage, and batteries. While for the nanotechnology and wind, the applications for the nanotechnology and wind represented by nanoparticle bearings, thin coatings, nanomaterials to strengthen the turbine. But for nanosolar, created from copper, indium, gallium selenide, CIGS, nanoparticles distributed throughout mixture, printed on nanoscale onto aluminum, 1 micron thick layer, and the efficiency is more than 17.1%. Also, nanofluids could be used as coolants for the nuclear. So the fluid film prevents boiling, loss of heat transfer. Nanoparticles prevent fluid film, aluminum oxide, and the efficiency is up to 40%. Other thing, the hydrogen storage. Carbon nanotube and graphene sheet, high surface area and porosity, allows for efficient storage of hydrogen and doping with lithium. Finally, the batteries are very necessary for our daily life, represented by cathode positive terminal, anode negative terminal, electrolyte charge, acidic gel, separates electrons to prevent electrical shortage to allow for the ion to flow. So the nanotechnology in lithium-ion batteries, has been granted the Nobel Prize in chemistry around 2020, I think so. For Godinez, he has passed away last year. So the scientists are currently implementing CNT into anode structure. This will replace traditional graphite anode and increase the holding capacity of lithium ions. Here is arising a new question. Will nanotechnology solve our energy crisis? So nanotechnology enabled energy production and distribution has the potential to solve a number of pressing energy issues. Reworking our enormous, highly integrated energy infrastructure will not be an easy task. How can this new technology fit into domestic energy policies to best the society? So here we need to educate the society, the generations, about implementing nanotechnology in our daily life. So the nanoparticles, okay, have several advantages, like the scope of and timetable of nanotechnology contribution to alternative and renewable energies is uncertain. Immediate action to address increasing energy costs and global climate change may be necessary, but the ultimate benefit, risk, and short-term effects of nanotechnology remain unknown. Also, there is a necessary task for the governments and corporations who will have to decide how nanotechnology will be used to generate and distribute energy. One model focuses on making existing power plants more efficient and developing new types of power plants. Another question, will nanotechnology improve living conditions around the world? Don't have access to safe drinking water, unfortunately. A new nanofiber water filter can remove bacteria, viruses, heavy metal, and organic material from water. They are relatively inexpensive and easy to use. So nanofilter could be widely employed in developing countries due to the pollution is very high percentage. And providing pure drinking water would help prevent disease in many parts of the world, but it wouldn't resolve many basic inequalities. Further question, can nanotechnology benefit? Yes. Affordable paint on solar energy technologies or drugs that targeted only the tumor and not the patient healthy cell. Currently, the majority of nanotechnology products available are targeted to wealthy consumers and such things as stain-resistant dress pants, smoothers, cosmetics, golf clubs, tennis rackets that are stronger and lighter. So this is the main feature of using the nanotechnology. But nanotechnology can also be used to address many problems, to being used for fighting disease. Nanotechnology has been employed to purify water, improve food preservation, and developing new materials used for shelter. Also, could be dangerous. There is a black or dark side of nanotechnology. Yes, everything has two faces or two sides, light and dark. So some nanotechnology are dangerous, but we use a lot of dangerous things today in our everyday lives. Gasoline, for example, is extremely toxic and flammable because its use is so prevalent and necessary. There are strict regulations about how gasoline can be produced, transported, and sold. Of course, there is always a chance for accident, but regulations help a great deal to make our use of gasoline safe. Sorry. A similar approach should apply to nanotechnology. We should use it when it is most beneficial for our needs, but develop regulations to prevent nanotechnology from being mishandled or applied in dangerous ways. The dangers posed by nanotechnology might be bigger than other technologies because or due to they are impossible to see and difficult to detect. And the ultimate dangers may not be seen for a long time. Scientists, engineers, social scientists, lawyers, and other specialists are already working to determine what are the effects of some applications will be helping us to understand nanotechnology much better. However, we can never know the full effect and dangers of a new technology until it is being regularly utilized. Nanotechnology is no exception. And the gasoline, this is gasoline is toxic and flammable. This is an answer for using dangerous technology. Gasoline could be dangerous, but it's useful. And we have regulations for producing, transporting, and using it safely. It is part of our daily life. So we rarely consider all the systems we have in place to make gasoline safe. But when emerging energy technologies hit the market, we will need to create new regulations to ensure safety. So this is the jurisprudence is very necessary to survive the technology in our daily life. The new applications of nanotechnology may be provide clean, efficient source of energy. If so, they will have a profound effect on our society. After all, our reliance on gasoline-powered transportation affect our daily lives, the design of our communities and our natural environment. Here are the journals. I am editor-in-chief of Experimental and Theoretical Nanotechnology. I invite all the participants to contribute to my journal, Experimental and Theoretical Nanotechnology. Also, I am associate editor for the nano micro letters. Impact factor is 26. peer-reviewed for many journals like Materials, Chemistry and Physics, Materials Science and Semiconductor Processing. Here is my patents using the nanotechnology, and my recent textbook published by Springer entitled Nanomaterials Basic to Application is available online to be purchased directly. Here is my recent book, Graphene, Nanotube, and Quantum Dot-Based Nanotechnology, Fundamental and Applications, edited by myself. A new book, Renewable Energy, Analysis, Resources, Applications, Management, and Policy, published by AIP Publisher. And this is chapter review, contributed to one of the Elsevier's book, Production of Powder Activated Carbon from Natural Resources. My recent paper published in Critical Review in Solid State and Material Science, Nanomaterials-Based Biosensor for COVID-19 Detection. And this is also another paper. In conclusion, the nanotechnology is difficult to regulate because they are hard to detect and define, and we don't really know how safe or dangerous they are. The challenge should be undergone to the skills of scientists and researchers for the best of humanity. Thank you so much for your kind listening.